Good evening everyone. Thank you for watching this video. I am Mr. Ish. Thank you for liking and for subscribing. We're taking a break and a step back here by looking at something here in pre-calculus. We will verify the law of sines using simple geometry and trigonometry principles. You know very quickly the formula is basically you can do sine A over A. That represents one dimension is equal to sine B over B. The angles here are in capitals. And then sine C over C, the lowercase letters represent sides. You can also present this formula in the exact reciprocal of each component where you can put the sides on the top and the angles on the bottom. The way we can verify this law of sines, how about we start with a triangle and we identify the sides and we will identify the angles. We can put over here A, B and C. These capitals are our angles. Opposing each angle is the corresponding side, right? You see that. What we can do is draw a height bisecting this lower line with this 90-degree line bisector, and we can look here at this angle A. When we look at this angle A, we do a sine A. With regards to this angle, we're looking at a corresponding height divided by the hypotenuse, which happens to be the side B. When we look at the same depiction over here and we're looking at everything here with regards to angle B, we're doing sine B. With regards to this, we have an opposite over hypotenuse, which is h over A. In each instance, you can solve for the h. In this top expression, you have B sine A is equal to h, which is equal to this, of course, right? Because the h is the same. A sine B. What we can do is store that expression and put it aside. Now we draw another triangle, a similar triangle. We can call this C, we can call this A, we can call it B, it doesn't matter. Just this time we're focusing here on C, and of course we will draw this height, which will create the right triangles, two of those. We have a corresponding side C, we have a corresponding side A, and a corresponding side B. When you're looking at this angle C, you can do sine of this angle C, and with regards to this you have an opposite over hypotenuse, which is h over A. With regards to this angle A over here, we're looking at sine A, and for this you have the opposite over hypotenuse, which is equal to h over C. Now in this expression we can basically solve for h again here. We have h. From here we're getting an A sine C, and then from here we're getting a C sine A, right? C sine A. Now what we can do is look at each of these expressions and we can convert them into ratios. We don't need this diagram anymore, so I'm going to erase it. When we look at that very top expression right there, what we end up seeing is we have B sine angle A is equal to A sine angle B, and then you can do a ratio development over here. Sine A over A is equal to sine B over B, and we can set this aside. When we look right over here, we have A sine angle C is equal to C sine angle A. Then again here we can develop the appropriate ratio. What we'll end up doing over here is we'll have sine angle C over its side C is equal to sine angle A over its side A. We can take this specific component right here, we know it's equal to that, and we can bring it right over here and we can just transpose it here, sine C over C, and the law of sines has been verified to be true using basic geometry and trigonometry. The geometric aspect here was the fact that we had a triangle with the identified sides and angles and all of that. We created a 90-degree or a perpendicular bisector to generate a right triangle from a triangle which did not have a right triangle, and then we could use the basic trigonometric functions, which was a trigonometry part, to take everything through to completion. So the procedure has been verified and everything is right here in front of you. In each instance the height was equal to that, and then we develop the appropriate ratios from those. Everything equals out, everything is verified. Thank you for watching. Have a nice day.